are predicted as the crime area and crime time, what crime place, okay, like that. Also, for example, during the end of the year party might be some crazy, okay. So they put the police patrol car, something like that. They can use this system for the new hire the policeman to have where you need the patrol. Some of the experienced guys, they know because of the experience. So probably this time because this is the end of the Halloween city, so we need to patrol more in the residential area to protect the kids, something like that. But such information may not be recognized by the policemen, so they can use this kind of system. So this is another example of using the big data. Then, finally, we are in the topic that we are mostly interested in as a computer science, right? So how to manage such a big data? What is this? Elephant, angry elephant. Why is the elephant? So we are going to use the Hadoop system. Hadoop is symbolized by this elephant. Name of this guy is the Hadoop. Actually, name of a toy. So author of this one is not the guy. So Tom White is also very popular. Doug Cuddy is a kind of father of the Hadoop system, who was in the employee in the Google, then moved to the Yahoo, then finally founded the Apache Hadoop Foundation. Then he was the founder of the Cloudera system. So it's kind of the father of the Hadoop system. He named this system once he saw his son's toy. It was called the Hadoop. So after that, many of the following software were named as animal, so pig, or hive, or sometimes zookeeper. So because of that, all software package related to the Hadoop is called Hadoop ecosystem. So we will see details about it. But the challenge is big. So it's bottom line is the technology. So even though we have the very high-end processing power and the computing power, bigger storage power, still limited to process such a huge amount of data, exabyte size data. So we need the new technology. Also individually, so we still lack of the experienced guy or the software engineer who knows such a big data concept. So to store the data, nowadays there are a lot of solutions like including Amazon and Hadoop and MongoDB and Cassandra and Teradata. Mostly we are talking about the Hadoop in this class. I did the Amazon Web Services, so using the virtual cloud system. But to do that, I need your credit card information to log on. But after you complete this course, I'm going to provide the document, so by yourself so you can use your Amazon account. Then some of the students are scared to open the account using your credit card. I did. So I forgot to delete all the machine that I create, and several months later, it's automatically build every time. So I realized I didn't clear my system, but don't forget to clear everything from but it's doable, so you don't have to purchase your system, the Hadoop system or whatever. You can just click, then you can create your Hadoop system using Amazon Web Services. But to understand the fundamental of the Hadoop, so we are going to use the virtual machine. So you will create your own virtual machine, the Hadoop system. Also you will set up the cluster system. The others, we will discuss the other MongoDB and Cassandra in the NoSQL database, not in this class. By the way, what is a MongoDB? It's called the NoSQL database. What is a NoSQL database? So opposite of SQL. Actually start from that because as I said, relational database model including SQL, is too much strict, right? It's modeled clearly, like this one. But our data doesn't fit to that strict, the model. So to address that problem, we have a more flexible data model that is called NoSQL database. Not only SQL. Nowadays it's called not only SQL. Because we cannot give up, we cannot throw away SQL, the traditional database. We still use the SQL and the relational database, but also we will use NoSQL database. MongoDB is a database for document, like the web page or XML page, like that. But we will see a little bit about the HBase database in this class, but not details of the NoSQL database. Traditionally, yes, we have a system to manage and store and handle such a big data. Mostly we try to parallelize, make a parallel system like MPI, okay? Massive parallel processing, or some other distributed system to increase. What's the main problem when you increase the number of system, the size of RAM, or the size of the disk drive? Complexity. We expect some linearly increase the performance as we add more computer in parallel system. However, output is not linearly increased. Sometimes it's going up but drop. Why? More complex. Okay? Think about the memory. Memory, they don't share. If you want to share the memory along the multiple server, it will be very, very complicated. Even multi-core system is not easy to manage such a share. If you do not share the memory information, some updated information in this node will not be accessed by the other. To do that, to address that problem, we can actually change the program, parallel program, make the module by module. This is the traditional way. Okay? Distributed system. Then it has a problem. Still struggling. So if you are taking the parallel programming course or the parallel system course, so you will learn how to design, okay, your program module to get the full benefit of this. So it's hard. It's hard to develop and manage a model. Okay? Storage is the same. However, nowadays we have the data-driven era. We need such a the high performance, the system, but traditional system may not. Okay. So computing power, including the processor and memory and storage, pretty much enough. But the data processing data is the big problem. So that is the reason it's called under the data-driven era world, the processing data is the big problem. So we need a new approach. Yeah. So before we think about the new approach, what is the requirement? So which means what is the problem of the traditional system? So partial failure support. Partial failure support means anyway, our idea is to add more and more computer nodes. What if one of them is a failed or there's something defective? Entire system should stop and fix it and run it again? No, that's not fair, because each and every node are doing their own job. Because one of the node is failure, we need to stop all the thing and do it again? No, it takes a long time. So your system, our system for big data management should support partial failure. Which means even though one of them is a failure, even though he's not interested in this course, we can replace him, then our class is going on. No, I don't want. I want to keep all the students. So support the partial failure. Even though we lose some of the data, but there should be able to recover such a failed data. Otherwise, however, sometimes in the big data era, unlike the relational database, sometimes it's not a big deal to lose some information because it's not deterministic. Okay, we don't. For example, in the average age of the total population of the entire world, is it very important to count him or not? Not much, right? Precision level is not 10 or 100, it's billions level, right? So think about such a data recoverability and so consistency. Even though the job or system is failed, we need to keep the consistency of the data. Okay? This is the most important, scalability. So our idea is to add more and more the system, but traditional system, when we add the more and more data, it's more complex and the overall performance is sometimes decreased or stopped. So we need scalable. Okay? The more node we add, the better performance we will get. That is the scalability. Our system should support such a scalability. Okay? Did we have the solution? Yes, we have the solution before, such as cloud computing. So cloud computing is still used. They adapt actually idea of the Hadoop system. Okay, so still survive like the Amazon Web Services, AWS. So what is the cloud computing? I'm going to quickly skip the cloud computing part. I'm not sure whether we still have the course regarding to the cloud computing. Do we have? No, I think that we had before, right? But the still cloud computing is important. So idea of the cloud computing is we consider everything as a service level. For the database, data is a service level of the data storage. Processor or computer, we provide service. So we can set up the computing environment on demand. That's the reason it's called a cloud. It's not fixed formation. It's a cloud formation. Okay? So to do that, we need automation, virtualization, pay as you go. So virtualization is you can. So we are going to use even the virtual machine. So virtualization, even though we have the one machine, but it can be viewed at several different machines. So virtualization. So Amazon Web Services is the most popular one, and Google App Engine I never use. First.com I never use, but Amazon Web Services even not only the company level, but the individual use the Amazon Web Services also. These are the lineup of the Amazon Web Service. So you can see the Elastic MapReduce is for data analytics. If you are interested in the data analytics using the MapReduce, you can use the Elastic MapReduce the service. Also, it has the virtual machine EC2. Using the EC2, I need 8 the core, the CPU, and 4 GB memory, and 100 node. Click, then you will have. Then storage, you can assign the storage. So then, but depending on how much you process, it will be built. Okay. It's not very expensive, but for individual, sometimes even though you don't do anything, but because of the setup, you pay the $30, $40. But for your practice, I recommend to use this Amazon Web Services. But this is our solution, that is a Hadoop-based ecosystem. Okay, so throughout the semester we will discuss about the Hadoop-based big data system. Okay, this is a very brief history of the Hadoop. Google realized that they have too many web pages, too big data, so they designed to something new system to collect all the web page quickly and the indexing. So that is called the Notch project. It's around 2000 year 2000 they did. So why Google is doing the Notch project? They realize they need a new file system. It should be a distributed file system. And also it should serve the partial failure. It should support something, the data recoverability. So that is called Google File System. So Google File System, then they successfully implement, then finally they release, okay, their algorithm. They publish it. So that is the, actually that was a sensation in the middle of 2000, 2004. Or 3, I cannot remember the exact year. Then everybody use that one, then Apache project is established, then finally Cloudera and so on. That is the Hadoop distributed file system. It's nothing but distributed file system. Is there anyone who took the My Operating System class for 2014? For 2014? No? I did a project, the personal portable file system, 2014. No one? What about this year? Is there anyone who is taking operating system? You are going to implement the portable file system. It's a similar idea. On top of existing file system, the HDFS, Hadoop distributed file system, additional one. So between Hadoop, the distributed file system, HDFS, and your own file system, you can in and out the file. So in your operating system class, you will implement a portable simple file system. If you understand HDFS, it's very easy to understand what is a portable file system. So that is the file system. Another thing is, what if we have the distributed file system, that means the HDFS, then how can I process such a data? So we need to get the full benefit of the distributed file system. So need the parallel processing. Traditional way of the processing is, one way is we design the modularity. So get the parallel processing benefit. Problem, hard to design the program. And also not easy customized. Okay? But if we had a new algorithm or additional module, it's not easy. So second approach was MPI approach. There is a program that can distribute the parallel job. But still, you cannot get the full benefit of the parallel processing because this MPI level do not know much about the hardware component like the HDFS. So we will need something parallel processing, the mechanism that is called map-reduce program. As the name implies, mapping. Okay? It's kind of grouping. Then process parallel. Okay? Then later after processing for each group, then reduce. Reduce is kind of combined. So it's a map-reduce approach. We will learn basically two things, HDFS and map-reduce. So this is, then Google release such a map-reduce. So both of the paper will be reading assignment. Okay? So first paper is the Google File System, that is the HDFS. So core hard concept is these two. Okay? The distributed file system and the map-reduced programming. So nowadays, most of all of the company, they are using the Hadoop. Okay. Most interesting part is the Oracle. Oracle has a long-time traditional relational database model. It's the exactly opposite of kind of the enemy of the big data system. Okay. They block actually the extension of the data. So because of that, data actually get out from the traditional database model. Nowadays, even Oracle claim they are supporting the head of big data system in their company. That's very interesting. That's actually too much power in the market. Oracle. IBM, yes. IBM actually all in everything to the big data. They actually closed many of the business sector to focus on the big data. Even one of my friends, the very close, we has been known almost 4 years from the elementary school. He was a designer of the semiconductor in Austin, IBM. He designed the chip, the processor chip, something like that. Then he moved to the IBM Watson in the White Plains. Then do you know what he is doing right now? He designed the power of the city. What is the relationship? Designing the chip and designing the city. It's an optimization of the power. When you design the chip, you need to optimize the power consumption. That's very important. Otherwise, it's very hot, your chip, right? Same thing, directly applied to when you design the city. How to design the grid, power grid. Okay, optimize the power line and put the power plant and the design. So because IBM focused on the big data, so using such a big data, they'd like to have the consulting or the design of the city level. So it's a very interesting changing. But anyway, IBM focus all of their source to the big data. So if you go to the IBM TJ Watson Center, there is a Watson showroom. So if you show the Watson showroom, there's something, the social media analysis, user profiling. There's some showcase and everything is the big data. And even Microsoft is direct to support the big data system. Okay. EMC, I think definitely because it's a storage company. But they try to move to the software company from hardware, but I don't know yet. I don't know recently. I do not have it. But they support provide something business intelligence tool, like the data mining tool and something like that. I'd like to continue the next week from this slide, but because this is the kind of overview of our entire semester. So it looks like complicated, but I will explain later. Then finalize the other slide. Okay. Data science and data analytics. This lecture is, I think, the most important part of the semester. The others are more technical part, which you like, right? So we will see more about the introduction of it. It's not just the introduction, it's a very details of the introduction of the course. Okay, any question?